All right, today we are opening up a cosmic cold case file. Seriously, it's this incredible story that has a brilliant theory, a mountain of evidence to back it up, and yet there's one crucial piece of the puzzle that seems to have vanished. This is the case of the missing lithium.
You know that feeling, right? That sinking feeling when you know you've made a mistake, but you have absolutely no idea where you went wrong. Well, that's pretty much what some of the world's top cosmologists are feeling when they look at the Big Bang. We've built this beautiful, almost perfect picture of how our universe began, but just like any jigsaw puzzle, if you find one single piece that doesn't fit, it forces you to question the entire picture.
For decades, the Big Bang Theory has been our most successful model for, well, everything. It explains so much, from the faint afterglow of creation that we can still detect to why galaxies are clustered the way they are. But there's this tiny flaw, this little crack in an otherwise magnificent theory. And believe it or not, it all comes down to one single element.
To really get what this mystery is all about, we have to go back, way back to the beginning. We have to investigate the crime scene itself, the first few minutes after the Big Bang. I mean, this was the hottest, densest furnace you could possibly imagine, and it was right there, in that inferno, that the key evidence, the very first elements, was forged.
What is just mind-blowing is how fast this all happened. So it all starts at time zero, the singularity. Just 1 second later, the universe is this searing sea of radiation at 10 trillion degrees Celsius. Way too hot for atoms. But then, by the 100-second mark, it's cooled down just enough to a chilly 1 trillion degrees for the strong nuclear force to kick in and start binding protons and neutrons together into the first atomic nuclei.
So in that initial cosmic fireball, the universe cooked up a very specific recipe of elements. And by looking closely at that recipe today, we can actually test our entire theory. So let's go ahead and open the evidence file.
The amazing thing about the Big Bang model is that it makes incredibly precise predictions for what this recipe should look like. It says we should get about 76% hydrogen, 24% helium, and then this teeny tiny trace amount of everything else. And you know what? When we look out at the oldest stars in the universe, our observations for hydrogen and helium match these predictions perfectly. It's a spectacular success for the theory.
But our whole mystery? It's hidden inside that tiny fraction of a percent. We're talking about lithium. Yep, the very same stuff that's probably in the battery of the device you're watching this on. With just 3 protons, our model says it should have been created in very small but very predictable amounts. And that prediction is a critical test of the whole shebang.
Because here's the thing. When we take that prediction and compare it to the evidence we've painstakingly gathered from the most ancient stars, the numbers just don't add up.
Okay, so here's problem number 1. For the most common type of lithium, called lithium-7, our theory predicts there should be a certain amount of it out there. But when we actually go and look, we consistently find only about a third of what we expect. 2/3 of it is just gone.
But wait, because the second part of the puzzle is even weirder. The other stable form, lithium-6, is predicted to be incredibly rare, like almost non-existent. And yet, our observations show it's about 1,000 times more abundant than it has any right to be. So we've got way too little of one and 1,000 times too much of the other. It's a total contradiction.
This is the fundamental challenge you face in science. When your data and your theory completely disagree, you're left with 2 main possibilities. Possibility 1, your theory is wrong, or at least incomplete. Possibility 2, your observations are wrong, you're misinterpreting the evidence. We basically have 2 suspects in our cosmic crime.
So let's investigate suspect number 1. Could our standard model of cosmology, the Big Bang theory itself, be incomplete?
Now, just throwing out the Big Bang model is not something you do lightly. I mean, it explains so many other cosmic observations perfectly. It feels too right to be a coincidence. But, and this is a big but, cosmology is an evolving branch of physics. Even the most foundational concepts are always open to revision when new, contradictory data comes along. And there's really no better example of this than Stephen Hawking himself. After championing the idea of the singularity, he later spent years trying to convince his peers that maybe, just maybe, that starting point didn't exist in the way we all thought it did. So if a concept that fundamental is on the table for discussion, then really, anything is possible.
All right, let's move on to our second suspect. What if the theory is actually fine, but our evidence is, well, tainted? Is it possible we're just not reading the cosmic clues correctly?
To measure these elements, scientists have to analyze incredibly faint light from ancient stars that's been traveling across the universe for billions of years. The specific signature for lithium in that light is unbelievably faint and ridiculously hard to measure accurately. It's kind of like trying to identify a single specific grain of sand on a beach that's on the other side of the planet.
And here's the real kicker, the stars themselves. The ancient stars we're looking at aren't perfect little time capsules. There are processes happening deep inside their cores, nuclear fusion, the slow churning of stellar material over billions of years that might actually be destroying the original Lithium-7 or even creating brand new Lithium-6. This would mean the evidence is getting contaminated before it even reaches our telescopes. The stars we see today might not be showing us what the primordial universe was actually like at all.
So where does all of this leave our investigation? Well, frustratingly, the case is still wide open. This cosmological lithium problem, as it's known, is still one of the biggest unsolved puzzles in all of science.
Right now, neither line of inquiry, a flawed model or flawed observations, has given us a definitive answer. The Big Bang model continues to be spectacularly successful in almost every other way, but the lithium data remains stubbornly, maddeningly inconsistent with what it predicts. That one piece of the puzzle still doesn't fit.
And this leaves us with a huge final question. We know a piece of our cosmic story is missing. When we finally find it, will it click perfectly into place and confirm this grand narrative we've built about the universe? Or will it be the one piece that forces us to take the entire puzzle apart and start writing a completely new story from scratch? The case continues.